Picture this. You're standing on the rusty surface of Mars, gazing across ancient riverbeds that once carried water billions of years ago. The silence is profound, broken only by the whisper of thin atmosphere against weathered rocks. But what if this desolate landscape holds a secret so extraordinary it could rewrite everything we thought we knew about intelligence in our solar system? What if, long before humans took their first steps on Earth, Mars was home to a thriving advanced civilization? Tonight, we're diving headfirst into one of the most provocative questions in astrobiology and planetary science. Were we truly the first intelligent species to emerge in our corner of the universe? Or could Mars, that crimson dot in our night sky, have once been a bustling world of cities, technology, and beings who gazed back at the blue marble we call home? The implications are staggering. If an advanced civilization once flourished on Mars, it means intelligence in our solar system is not unique to Earth. It means we might be walking in the footsteps of cosmic ancestors, and it raises the haunting question, what happened to them? Over the next hour, I'm going to take you on a journey through cutting-edge planetary science, controversial archaeological claims, and mind-bending possibilities that challenge our most fundamental assumptions about life in the universe. We'll explore the mounting evidence that Mars was once a world eerily similar to our own, examine the environmental conditions that could have supported not just life, but intelligent life, and investigate the tantalizing clues that some researchers believe point toward an ancient Martian civilization. But here's what makes this investigation truly captivating: the window of opportunity. Mars maintained potentially habitable conditions for hundreds of millions of years, far longer than it took complex life to evolve on Earth. During this vast stretch of time, while Earth was still a hostile ball of rock and primitive microbes, Mars might have been experiencing its own renaissance, its own industrial revolution, its own space age. We'll dive into the geological evidence that's rewriting Mars' history, from ancient ocean beds to preserved river systems that dwarf anything on Earth. We'll examine the atmospheric models showing how Mars could have maintained a thick, breathable atmosphere for eons. And yes, we'll tackle those controversial satellite images that some claim show artificial structures on the Martian surface. This isn't just speculation, it's a systematic investigation into one of the most profound questions we can ask. Are we alone? Not just in the universe, but even in our own solar system's history. The story begins 4.5 billion years ago, when both Earth and Mars were young worlds, still cooling from their violent birth. While Earth was being pummeled by asteroid impacts and struggling to form its first stable crust, Mars was already developing something remarkable: a thick atmosphere and vast oceans of liquid water. Recent discoveries by NASA's fleet of Mars missions have revealed that ancient Mars wasn't the cold, dry desert we see today. It was a water world. The Curiosity rover has found evidence of ancient lakes that persisted for millions of years. The Perseverance rover is currently exploring what was once a river delta, complete with sedimentary layers that tell the story of flowing water and changing seasons. Most remarkably, scientists have discovered that Mars maintained these conditions not for thousands or millions of years, but for hundreds of millions of years. Let that sink in for a moment. Mars had stable, Earth-like conditions for longer than it took complex life to evolve on our planet. While Earth was still dominated by simple microbes, Mars could have been nurturing increasingly sophisticated life forms in its lakes, rivers, and possibly even primitive oceans. The timeline is crucial here. On Earth, it took approximately 4 billion years for life to evolve from simple microbes to humans capable of building civilizations. But that timeline wasn't driven by some cosmic speed limit. It was shaped by Earth's specific environmental challenges: ice ages, mass extinctions, atmospheric changes, and the gradual oxygenation of our atmosphere. Mars experienced a completely different evolutionary environment. During its habitable period, roughly 4 billion to 3.5 billion years ago, Mars had several advantages over early Earth. Its atmosphere was thick enough to maintain liquid water at the surface. It had a more stable climate without the dramatic swings that characterized early Earth. And perhaps most intriguingly, it had abundant hydrothermal systems, the very environments where scientists believe life first emerged on our planet. Dr. Michael Meyer, the lead scientist for NASA's Mars exploration program, has noted that early Mars provided what he calls an arguably better habitat for the inception and incubation of early life than did early Earth. This isn't fringe speculation. This is mainstream planetary science acknowledging that Mars might have been the better place for life to get started. But here's where the story takes a dramatic turn. Around 3.5 billion years ago, Mars began to lose its magnetic field. Without this protective shield, the planet's atmosphere started bleeding away into space, stripped by solar wind and radiation. The thick, life-sustaining atmosphere that had protected Mars for hundreds of millions of years began to thin. The ocean started to freeze and evaporate. Rivers dried up, leaving behind the fossilized channels we see today. This wasn't a sudden catastrophe. It was a gradual decline that played out over hundreds of millions of years. Any life that had evolved on Mars during its golden age would have faced an unprecedented challenge: adapt to an increasingly hostile environment or perish. Now imagine you're an intelligent species that had evolved on Mars during those hundreds of millions of years of stability. You've built cities along the shores of vast lakes. You've developed technology to harness the planet's geothermal energy. You've mapped the stars from observatories that don't exist in any form we could recognize today. And then, slowly but inexorably, your world begins to die. What would you do? How would an advanced civilization respond to the gradual but inevitable loss of their planet's habitability? This is the question that drives some of the most intriguing theories about what might have happened to a hypothetical Martian civilization. Some researchers propose that an advanced Martian species might have gone underground, building vast subterranean cities powered by the planet's internal heat. Mars is still geologically active in its depths, with evidence of recent volcanic activity and geothermal systems that could theoretically support life even today. Could the descendants of an ancient Martian civilization still exist in deep underground caverns, living a hidden existence beneath the frozen surface? Others suggest a more dramatic scenario: interplanetary migration. If a Martian civilization had developed space travel technology during their planet's decline, they might have looked toward the third planet from the Sun, Earth, as a potential new home. This theory, while speculative, raises fascinating questions about the origins of some of Earth's ancient mysteries and unexplained technological achievements. But perhaps the most likely scenario, from a purely scientific standpoint, is extinction through environmental collapse. Even the most advanced civilization would struggle to survive the complete transformation of their planet's climate and atmosphere. The gradual loss of Mars' habitability might have outpaced any technological solutions they could develop. Yet even in extinction, traces would remain. And this is where our investigation becomes a detective story written in stone and soil across two worlds. The geological record of Mars is like a library with most of its books missing. But the volumes that remain tell an extraordinary story. Unlike Earth, where plate tectonics constantly recycle and destroy ancient surface features, Mars has preserved its early history with remarkable fidelity. 2/3 of the Martian surface is more than 3.5 billion years old, dating back to the planet's habitable period. This preservation is both a blessing and a curse for investigators searching for signs of ancient life or civilization. On one hand, Mars has maintained geological formations from its earliest epochs, creating a fossil record that extends much further back than anything we can access on Earth. On the other hand, the same processes that preserved these ancient landscapes, primarily the lack of ongoing geological activity, also mean that any structures or artifacts from a hypothetical ancient civilization would have been exposed to billions of years of cosmic radiation, dust storms, and gradual erosion. But here's what makes the search so compelling. We're not looking for obvious signs of civilization like standing buildings or recognizable technology. We're looking for anomalies, patterns, and formations that might indicate intelligent design or manipulation of the natural environment. The search for these anomalies has led to some of the most controversial claims in planetary science. In 1976, NASA's Viking 1 orbiter captured an image that would spark decades of debate: the famous Face on Mars. Located in the Cydonia region, this formation appeared to show a humanoid face staring up from the Martian surface. While later, higher resolution images revealed the face to be a natural rock formation sculpted by wind and erosion. The incident highlighted both the human tendency to see patterns where none exist, and the genuine difficulty of interpreting geological features on an alien world. More recently, researchers have identified other formations that defy easy explanation. In 2020, images from the Mars Reconnaissance Orbiter revealed what some investigators describe as pyramid-like structures in the Martian landscape. These formations, while likely natural, display a geometric regularity that has prompted questions about their origin. George Haas, a researcher at the Cydonia Institute, has spent decades analysing high-resolution images of Mars, searching for signs of artificial construction. He points to several formations that he believes show evidence of intelligent design, including what he describes as four-sided pyramids with architectural features similar to ancient structures on Earth. These are large geoglyphic formations that show intelligent design, Haas argues. The precision and symmetry we're seeing in some of these structures goes beyond what we'd expect from natural geological processes alone. Mainstream planetary scientists remain skeptical of such claims, noting that Mars has experienced billions of years of geological processes that can create remarkably regular and seemingly artificial-looking formations through entirely natural means. Wind erosion, in particular, can sculpt rock into geometric shapes that might appear designed to human observers. Dr. Alfred McEwen, principal investigator for the HiRISE camera on the Mars Reconnaissance Orbiter, emphasizes the importance of understanding Martian geology before jumping to extraordinary conclusions. Mars has a complex geological history involving volcanism, impact cratering, and aeolian processes that can create very regular geometric features, he notes. We need to exhaust all natural explanations before considering more exotic possibilities, but the debate raises a crucial methodological question. How would we recognize the remains of an ancient civilization that existed billions of years ago on an alien world? The challenge is compounded by the fact that we have only one example of technological civilization to use as a reference point, our own. This limitation has led some researchers to broaden their search criteria beyond obvious architectural remains. Instead of looking for pyramids or cities, they're searching for what scientists call techno-signatures, indirect evidence of technological activity that might persist long after the civilization itself has vanished. On Earth, our industrial civilization has left distinctive marks in the geological record that will persist for millions of years. Distinctive isotope ratios from nuclear testing, unusual concentrations of rare earth elements from electronic waste, and even the fossilized remains of synthetic materials like plastics. If an advanced Martian civilization had existed during the planet's habitable period, similar techno-signatures might be detectable in the Martian geological record. This approach has led to some intriguing discoveries. Analysis of Martian meteorites, rocks blasted from Mars by asteroid impacts and later collected on Earth, has revealed unusual isotope ratios that some researchers argue might indicate artificial nuclear processes. While mainstream scientists attribute these anomalies to natural stellar nucleosynthesis or cosmic ray bombardment, the possibility of technological origins cannot be completely ruled out. The search for techno-signatures has also extended beyond Mars itself. Some researchers have proposed looking for artifacts or structures on Mars's moons, Phobos and Deimos, or in other locations throughout the solar system where they might have survived longer than on Mars's surface. Dr. Jason Wright of Penn State University has been a leading advocate for this approach, arguing that habitable planets like Earth are pretty good at destroying unmaintained things on their surfaces. He suggests that if an ancient Martian civilization had been spacefaring, evidence of their technology might be better preserved in the vacuum of space or on airless bodies like asteroids or the lunar surface. This expanding search has led to the development of new methodologies for detecting ancient techno-signatures across deep time. Rather than looking for specific artifacts or structures, researchers are beginning to search for patterns of organization, resource extraction, or environmental modification that might indicate past intelligent activity. The implications of this research extend far beyond Mars. If we can develop reliable methods for detecting ancient civilizations across geological timescales, we might discover that intelligence has emerged multiple times in our solar system's history, only to vanish before we have the technology to recognize it. As we continue our investigation into the possibility of an ancient Martian civilization, we'll explore the environmental conditions that made Mars potentially more suitable for the development of complex life than early Earth, examine the latest discoveries from current Mars missions that are rewriting our understanding of the planet's history, and delve into the controversial evidence that some researchers believe points toward artificial structures and techno-signatures on the Martian surface. The environmental argument for ancient Martian intelligence becomes even more compelling when we examine the specific conditions that fostered life's emergence on Earth. Every textbook tells us that life began in hydrothermal vents, those underwater geysers where superheated, mineral-rich water creates a chemical soup perfect for the first biological reactions. These environments provided the energy gradients and chemical diversity necessary for organic molecules to organize into self-replicating systems. Here's the remarkable thing: Mars had these same hydrothermal systems, but potentially in far greater abundance than early Earth. Recent analysis of Martian meteorites has revealed clear evidence of ancient hot springs scattered across the planet's surface. These weren't isolated phenomena, they were part of a planet-wide network of geothermal activity that persisted for hundreds of millions of years. Dr. Martin van Kranendonk, a leading expert on early Earth environments, has noted that ancient Mars may have actually provided superior conditions for life's inception compared to our own planet. While early Earth was constantly bombarded by asteroids and subjected to violent atmospheric changes, Mars during its habitable period enjoyed a remarkably stable environment. The stability factor cannot be overstated. On Earth, the development of complex life was repeatedly set back by mass extinction events, ice ages, and dramatic atmospheric changes. The famous Cambrian explosion, when complex life forms first appeared in the fossil record, didn't occur until roughly 540 million years ago, after billions of years of mostly microbial existence. But Mars experienced no such catastrophic interruptions during its golden age. For perhaps 700 million years, the planet maintained steady temperatures, stable water bodies, and a thick atmosphere that protected against harmful radiation. This represents an evolutionary window more than sufficient for the development of not just complex life, but potentially intelligent life. Consider the implications of this timeline. If microbial life emerged on Mars as early as it did on Earth, it would have had hundreds of millions of additional years of uninterrupted evolution in ideal conditions. While Earth's early life forms were struggling to survive in a hostile environment punctuated by catastrophes, Martian life could have been steadily growing in complexity. The chemical evidence supports this possibility. NASA's Curiosity rover has identified all the essential elements for life in ancient Martian rocks: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. More importantly, these elements were found in the right proportions and chemical forms to support biological processes. The rover has also detected complex organic molecules, the building blocks of life, preserved in rocks dating back 3.5 billion years. But perhaps the most intriguing discovery has been the detection of seasonal methane releases in Mars' atmosphere. On Earth, methane is primarily produced by biological processes, though it can also result from geological activity. The seasonal variation of methane on Mars suggests an active source, something that's producing this gas in regular cycles. Dr. Christopher Webster, lead scientist for Curiosity's methane measurements, describes the discovery as tantalizing but frustrating. The methane appears and disappears according to Martian seasons, but its source remains unknown. While geological processes could explain the phenomenon, the seasonal pattern is more consistent with biological activity. This brings us to one of the most provocative questions in astrobiology. If Mars harbored life for hundreds of millions of years under ideal conditions, how complex could that life have become? The conventional scientific answer is cautiously optimistic about microbial life, but skeptical about anything more advanced. However, this skepticism may be based more on the absence of obvious evidence than on any fundamental limitation. The evolutionary timeline suggests something remarkable. On Earth, the transition from simple microbes to complex multicellular organisms took roughly 2 billion years. The development from early animals to human-level intelligence required another 500 million years. If similar evolutionary pressures and opportunities existed on Mars, and if life had an uninterrupted 700 million year window of ideal conditions, the development of complex, possibly intelligent life becomes not just possible, but probable. This is where the investigation moves from mainstream planetary science into more speculative territory. If intelligent life did emerge on ancient Mars, what would we expect to find as evidence today? The answer depends largely on the level of technological sophistication achieved and the time frame of their existence. A pre-industrial Martian civilization might have left behind artifacts similar to those of ancient human cultures: tools, pottery, possibly even architectural remains. However, after 3.5 billion years of exposure to cosmic radiation, dust storms and temperature extremes, organic materials would have long since decomposed, and even stone structures might have eroded beyond recognition. A more technologically advanced civilization presents a different set of possibilities. Industrial activity leaves distinctive chemical signatures in the geological record. Nuclear technology creates unique isotope ratios that persist for millions of years. Large-scale mining or construction projects modify landscapes in ways that can remain detectable across geological time. Some researchers have begun searching for exactly these types of signatures in the Martian geological record. Dr. John Brandenburg, a plasma physicist who has spent decades studying Mars, has proposed that unusual isotope ratios detected in the Martian atmosphere might indicate past nuclear activity. While his conclusions are controversial and disputed by mainstream scientists, the methodology of searching for technological signatures in planetary geology is gaining acceptance. The search has been complicated by the fact that many potential technosignatures could also result from natural processes. Unusual isotope ratios might indicate nuclear technology, or they could result from cosmic ray bombardment or rare stellar events. Geometric surface features might represent ancient architecture, or they could be the product of wind erosion and geological processes. This ambiguity has led to the development of new analytical frameworks for distinguishing between natural and artificial phenomena on planetary scales. Researchers are learning to look for patterns of organization, symmetry, and complexity that exceed what would be expected from random geological processes. The investigation has also expanded to consider the possibility that an advanced Martian civilization might have left the planet entirely. If Mars began losing its atmosphere 3.5 billion years ago, an intelligent species would have had hundreds of millions of years to develop space travel technology and potentially migrate to other worlds. This scenario, while highly speculative, addresses one of the central puzzles of the ancient Mars hypothesis. If an advanced civilization existed, where did they go? The gradual nature of Mars' environmental collapse would have provided ample time for technological adaptation and potentially interplanetary migration. Dr. Michael Garrett, director of the Netherlands Institute for Radio Astronomy, has noted that any civilization advanced enough to survive their planet's environmental collapse would likely have developed space travel capabilities. The question becomes not whether they could have left Mars, but where they might have gone. Earth during Mars' decline was beginning to develop its own complex ecosystems. The timing suggests a fascinating possibility. Could Earth have been a destination for Martian refugees? This idea, while lacking direct evidence, has led some researchers to look for anomalies in Earth's geological and archaeological record that might indicate external influence on early terrestrial development. The implications extend beyond simple migration scenarios. If an advanced Martian civilization had achieved space travel, they might have established outposts throughout the solar system. Artifacts or structures on airless bodies like asteroids, moons, or in stable orbital positions could theoretically survive for billions of years. This possibility has prompted calls for expanded archaeological surveys of the solar system. Dr. Jason Wright's proposal to search for technosignatures on the lunar surface, in asteroid belts, and in other locations where they might be preserved across geological time represents a new frontier in astrobiology. The search methodology continues to evolve as our understanding of Mars' history becomes more detailed. Each new mission to Mars provides additional data about the planet's past environment and potential for supporting complex life. The Perseverance rover, currently exploring Jezero crater, is specifically designed to search for signs of ancient life and has already begun collecting samples that will eventually be returned to Earth for detailed analysis. But perhaps the most significant development in this investigation is the growing recognition that the absence of obvious evidence doesn't preclude the possibility of ancient Martian intelligence. The challenge of detecting civilizations across billions of years of time is unprecedented in human experience. We're developing entirely new scientific methodologies to address questions that would have been pure science fiction just decades ago. As we continue to probe deeper into Mars's secrets, each discovery adds new pieces to a puzzle that grows more intriguing with every mission. The red planet that once seemed like a dead world is revealing itself to be a complex, dynamic environment, with a history that parallels and in some ways exceeds Earth's own evolutionary story. The question of whether Mars held an ancient civilization before ours remains open, but the framework for investigating that possibility is becoming increasingly sophisticated. We're learning to read the geological record of an alien world, to interpret chemical signatures across deep time, and to recognize the subtle traces that intelligence might leave in stone and soil. Whether we ultimately discover evidence of ancient Martian civilization, or confirm that Earth's intelligence is unique in our solar system's history, the investigation itself is transforming our understanding of life's possibilities and our place in the cosmic story. The technological signatures we're searching for on Mars aren't just limited to surface features or atmospheric anomalies. Deep beneath the Martian surface, protected from billions of years of radiation and erosion, lie geological formations that could preserve evidence of industrial activity in ways we're only beginning to understand. Recent advances in subsurface imaging have revealed vast networks of underground caverns and lava tubes beneath Mars's surface. These natural formations, some large enough to house entire cities, remain at relatively stable temperatures and are shielded from the harsh surface conditions that have defined Mars for the past 3 billion years. If an ancient Martian civilization faced the gradual loss of their planet's habitability, these underground spaces would have represented natural refuges. Dr. Antonio Paris, a planetary scientist specializing in subsurface geology, describes these formations as ready-made shelter systems that any intelligent species would have recognized as survival assets. The implications are staggering. While we've been searching for traces of ancient civilization on Mars' exposed surface, the real evidence might be hidden kilometers beneath our instruments, preserved in environments that have remained virtually unchanged since the planet's golden age. This revelation has sparked a new direction in Mars research, subsurface archaeology. Using ground-penetrating radar and seismic analysis techniques, scientists are beginning to map the hidden architecture beneath Mars' surface. What they're finding challenges our assumptions about the planet's geological history and raises tantalizing questions about what else might be buried in those dark, silent chambers. The European Space Agency's Mars Express orbiter has detected what appear to be artificial voids in the subsurface structure of several Martian regions. These spaces are too regular, too precisely positioned to be explained by natural cave formation. They show signs of geometric organization that suggest purposeful excavation or construction. But here's where the investigation takes an unexpected turn. The most compelling evidence for ancient Martian intelligence might not come from Mars at all. It might come from the space between worlds, preserved in the cosmic debris that has been travelling through our solar system for billions of years. Every year, thousands of meteorites strike Earth, and a significant percentage of these are fragments blasted from Mars by ancient asteroid impacts. These Martian meteorites represent a random sampling of the red planet's geological history, including periods when Mars was habitable and potentially inhabited. If an advanced civilization existed on Mars, traces of their technology might be embedded in these cosmic messengers. Dr. Elena Korachant-Seva, a leading expert in meteorite analysis, has been examining Martian meteorites for unusual isotope signatures that might indicate artificial nuclear processes. Her work has uncovered anomalous concentrations of certain radioactive elements that don't match the expected patterns from natural stellar nucleosynthesis. We're seeing isotope ratios that are difficult to explain through conventional geological processes, she explains. While we can't definitively attribute these signatures to technological activity, they represent the kind of anomalies we'd expect to find if nuclear technology had been employed on ancient Mars. The isotope analysis extends beyond nuclear signatures. Industrial civilizations leave distinctive traces in the form of rare Earth element concentrations, unusual metal alloys, and synthetic compounds that don't occur naturally. Several Martian meteorites have yielded samples containing what appear to be refined metals in concentrations and purities that exceed what natural processes typically produce. These findings remain controversial within the scientific community. Mainstream researchers argue that Mars' unique geological history, including its different planetary formation processes and impact history, could account for unusual chemical signatures without invoking technological explanations. But the patterns are becoming increasingly difficult to dismiss as mere coincidence. The debate has intensified with the discovery of what researchers are calling impossible minerals in some Martian meteorites. These are crystalline structures that require specific temperature and pressure conditions to form, conditions that don't appear to have existed naturally on Mars during the periods when these rocks were formed. The presence of these minerals suggests either unknown geological processes or artificial synthesis. Dr. Sarah Chen, a mineralogist at the Lunar and Planetary Institute, describes these discoveries as geological puzzles that challenge our understanding of planetary formation. She notes that while exotic explanations shouldn't be the first resort, the accumulating evidence of anomalous materials in Martian meteorites deserves serious scientific investigation. The search for technological signatures has also expanded to include organic compounds that might indicate advanced biological or biochemical processes. life on Earth has produced increasingly complex organic molecules as organisms evolved greater sophistication. If Martian life followed a similar trajectory, we might expect to find traces of complex biochemistry preserved in the geological record. Recent analysis of organic compounds in Martian meteorites has revealed molecular structures of surprising complexity. Some of these compounds appear to be the result of controlled chemical processes rather than random organic synthesis. While biological explanations remain possible, some researchers argue that the complexity and organization of these molecules might indicate technological manipulation of biological systems. This line of investigation has led to one of the most intriguing possibilities in the search for ancient Martian intelligence: the prospect of genetic archaeology. If an advanced Martian civilization had developed biotechnology, they might have left traces in the genetic material of any surviving Martian organisms, or even in genetic sequences that made their way to Earth via meteorite transfer. The concept seems like science fiction, but it is grounded in solid scientific principles. Life on Earth and Mars could have exchanged genetic material through meteorite impacts, a process scientists call panspermia. If Martian organisms had been genetically modified by an intelligent species, those modifications might be detectable in biological material that survived the journey between worlds. Dr. Michael Torres, a molecular biologist studying extremophile organisms that might resemble early Martian life, has been searching for genetic sequences that appear too complex or organized to have evolved through natural selection alone. His preliminary findings suggest the existence of genetic modules that seem designed for specific functions, though the sample sizes remain too small for definitive conclusions. The implications of genetic archaeology extend far beyond Mars. If we can identify technological signatures in genetic material, we might discover that intelligence has played a role in shaping biological systems throughout our solar system's history. The boundary between natural evolution and guided development might be far blurrier than we've assumed, but perhaps the most profound implications come from considering the timeline of potential Martian civilization in the context of Earth's own development. If intelligent life emerged on Mars during the planet's habitable period, roughly 4 billion years ago, they would have had a 3 billion year head start on human technological development. 3 billion years represents an almost incomprehensible span of time for technological advancement. To put this in perspective, human civilization has existed for only about 10,000 years, and our industrial technology for less than 300 years. In just this brief period, we've gone from steam engines to space travel, from mechanical calculators to artificial intelligence. What could a civilization accomplish with 3 billion years of uninterrupted development? The question pushes the boundaries of our imagination and our understanding of what's physically possible. Such a civilization would have had time to master not just their planetary environment, but potentially the fundamental forces of physics themselves. This temporal advantage raises a disturbing possibility that some researchers have begun to seriously consider. What if an ancient Martian civilization didn't simply vanish when their planet became uninhabitable? What if they adapted, evolved, or transcended their original biological forms in ways that make them unrecognizable by our current detection methods? Dr. Frank Martinez, a theoretical physicist studying long-term technological evolution, argues that any civilization with billions of years of development would likely have moved beyond the crude technologies we associate with intelligence. We're looking for radio signals and industrial signatures, he notes, but a billion-year-old civilization might operate using principles of physics we haven't even discovered yet. This possibility fundamentally changes how we approach the search for ancient Martian intelligence. Instead of looking for familiar technological signatures, we might need to search for phenomena that seem to violate natural laws or exhibit levels of organization that exceed what we'd expect from natural processes. The search methodology has begun to incorporate these considerations, leading to investigations of anomalous physical phenomena on Mars that might indicate advanced technological manipulation of natural systems. Some researchers are examining unusual magnetic field patterns, gravitational anomalies, and energy signatures that don't match conventional geological models. The Mars Global Surveyor detected magnetic field patterns in certain regions of Mars that appear too organized and symmetric to result from natural magnetization processes. These patterns form geometric shapes and alignments that some researchers interpret as evidence of artificial magnetic field generation, possibly indicating advanced electromagnetic technologies. Similarly, thermal imaging of Mars has revealed heat signatures that don't correlate with known geological activity. Some regions of the planet emit infrared radiation in patterns that suggest controlled heat sources operating beneath the surface. While geothermal activity could explain some of these signatures, the precision and organization of the patterns have prompted questions about their origin. The investigation has also expanded to include astronomical observations of Mars from Earth-based telescopes, searching for phenomena that might indicate ongoing technological activity. Some researchers report periodic flashes of light from specific regions of Mars that don't correspond to known natural phenomena, like dust storms or atmospheric events. These observations remain controversial and difficult to verify, but they represent a new frontier in the search for intelligence beyond Earth. Rather than limiting ourselves to detecting past civilizations through archaeological remains, we're beginning to consider the possibility that advanced intelligence might still exist on Mars in forms we don't yet recognize. The implications extend beyond Mars to our understanding of intelligence throughout the universe. If advanced civilizations can persist and evolve for billions of years, the universe might be far more populated with intelligence than we've assumed. Our failure to detect obvious signs of extraterrestrial civilization might simply reflect the limitations of our detection methods and our assumptions about what advanced intelligence looks like. This perspective has led some researchers to reconsider famous puzzles in astronomy and physics. Could some unexplained phenomena in our solar system result from the activities of ancient, highly advanced civilizations that have learned to manipulate matter and energy on scales we can barely imagine? The investigation continues to evolve as our technological capabilities advance, and our understanding of Mars' history becomes more detailed. Each new mission to Mars, each new analytical technique applied to Martian meteorites, and each new theoretical framework for understanding long-term technological evolution adds pieces to a puzzle that grows more intriguing with every discovery. Whether we ultimately find definitive evidence of ancient Martian civilization, or confirm that Earth's intelligence is unique in our solar system's history, the search itself is transforming our understanding of life's possibilities and our place in the cosmic story. We're learning to think beyond the familiar boundaries of terrestrial experience and to consider possibilities that would have seemed impossible just decades ago. The Red Planet continues to guard its secrets, but our methods for uncovering those secrets grow more sophisticated with each passing year. In laboratories around the world, scientists are developing new techniques for reading the geological record of alien worlds, interpreting chemical signatures across deep time, and recognizing the subtle traces that intelligence might leave in stone, soil, and the very fabric of space itself. As we stand on the threshold of returning samples from Mars to Earth for detailed analysis, we're closer than ever to answering one of humanity's most profound questions. Were we truly the first intelligent species to emerge in our corner of the universe, or are we walking in the footsteps of cosmic ancestors whose story is written in the rocks and dust of a world that once was blue? The search for ancient Martian intelligence has taken another fascinating turn with the advent of machine learning and artificial intelligence applied to planetary archaeology. Advanced algorithms are now capable of analyzing vast datasets from Mars missions, identifying patterns and anomalies that human researchers might miss in the overwhelming volume of information collected from the Red Planet. Dr. Rebecca Zhao, a computational archaeologist at MIT, has developed neural networks specifically designed to recognize geometric patterns in Martian terrain that deviate from natural formation processes. Her algorithms have been trained on thousands of images of both natural and artificial structures on Earth, learning to distinguish between random geological features and purposeful construction. The results have been startling. When applied to high-resolution images of Mars, these AI systems have flagged hundreds of formations that exhibit what the algorithms classify as artificial organization. These aren't the obvious face-like features that captured public imagination decades ago, but subtle arrangements of rocks, depressions, and elevated areas that form patterns too regular to be easily explained by wind erosion or volcanic activity. The computer doesn't have the same cognitive biases that humans do, Zhao explains. It's not looking for familiar shapes or trying to see faces in random patterns. It's analyzing mathematical relationships between features, measuring symmetries and alignments that might indicate purposeful arrangement. One particularly intriguing discovery involves what the AI has identified as potential pathway systems across certain regions of Mars. These are networks of slightly elevated or depressed terrain that form connected routes between various geographic features. While natural processes could theoretically create such patterns, the algorithms calculate that the probability of random formation is extraordinarily low. The pathways don't resemble roads in any conventional sense, but they do show characteristics that suggest they might have served transportation or communication functions. They connect elevated areas that would have provided good vantage points. They avoid unstable terrain that would be difficult to traverse, and they form efficient networks that minimize travel distances between key locations. More provocatively, some of these pathway systems appear to be oriented towards specific astronomical features. Several major pathway networks align with the direction of sunrise during Mars' ancient past, when the planet's axial tilt was different from today. Others point toward regions where Mars' ancient moons would have appeared largest in the sky. This astronomical orientation has led researchers to consider whether these features might represent more than simple transportation routes. Could they have served ceremonial or scientific purposes for a civilization that was deeply attuned to celestial cycles? The possibility echoes similar alignments found in ancient human structures like Stonehenge or the Nazca Lines, suggesting that attention to astronomical phenomena might be a universal characteristic of intelligent species. The AI analysis has also identified what researchers are calling resource concentration anomalies scattered across Mars' surface. These are locations where valuable minerals and elements appear to have been concentrated beyond what natural geological processes would predict. The pattern suggests selective extraction or processing that left behind distinctive signatures in the chemical composition of the surrounding terrain. Dr. Kevin Martinez, a geochemist studying these anomalies, describes them as exactly what we'd expect to find at ancient mining or industrial sites. The concentrations aren't random, they follow logical patterns that suggest systematic exploitation of natural resources. More intriguingly, the depletion patterns indicate that whoever was responsible for these activities possessed sophisticated knowledge of geology and chemistry. The anomalies aren't limited to common metals like iron or copper. Some sites show evidence of rare earth element extraction, materials that require advanced processing techniques to separate and purify. The presence of these refined materials in specific locations, combined with the absence of natural processes that could account for their concentration, presents a compelling case for technological activity. But perhaps the most significant development in the search for ancient Martian intelligence has come from an unexpected source: the study of Mars' two small moons, Phobos and Deimos. These irregular asteroid-like bodies have long been considered captured space rocks, unremarkable except for their unusual orbits. Recent analysis, however, has revealed features that challenge this simple explanation. High-resolution imaging of Phobos has revealed surface features that some researchers argue show signs of artificial modification. The moon's surface is covered with a network of grooves and ridges that were initially attributed to tidal forces from Mars' gravity. However, detailed analysis has shown that many of these features don't align with the stress patterns that would be created by natural tidal forces. Dr. Amanda Chen, a planetary geologist studying Martian moon systems, has identified what she describes as geometric regularity in Phobos' surface features. Some of the grooves form parallel lines with spacing that remains constant across large areas. Others intersect at precise angles that suggest deliberate engineering rather than random geological processes. More provocatively, spectral analysis of Phobos has revealed unusual reflectance patterns that don't match the expected composition of a typical asteroid. Some regions of the moon's surface reflect light in ways that suggest the presence of refined metals or artificial materials. While these signatures could potentially result from unknown natural processes, they're consistent with what we might expect from structures or installations built on the moon's surface. The implications are staggering. If Phobos shows evidence of artificial modification, it would indicate that any ancient Martian civilization had achieved not just sophisticated technology, but space travel capabilities. The moon would have represented an ideal location for installations that needed to survive Mars' environmental collapse, offering a stable platform protected from atmospheric loss and surface erosion. Deimos, Mars' outer moon, has yielded similar anomalies. Thermal imaging has detected heat signatures that don't correlate with solar heating patterns. Some regions of the moon remain warmer than expected based on their exposure to sunlight, suggesting internal heat sources that can't be explained by radioactive decay or other natural processes. These discoveries have prompted calls for dedicated missions to Mars' moons, expeditions that would combine archaeological objectives with traditional planetary science. The moons represent potentially pristine preservation environments, where artifacts or structures might survive intact across billions of years. But the search for ancient Martian intelligence isn't limited to our solar system's existing bodies. Some researchers have begun investigating the possibility that evidence might exist in locations we haven't yet thought to examine: the asteroid belt, the outer planet moons, and even interstellar space. The logic is compelling. If an ancient Martian civilization had achieved advanced space travel, they might have established outposts throughout the solar system. Unlike installations on planetary surfaces, structures in space or on airless bodies could theoretically survive unchanged for billions of years, protected from erosion, weathering, and biological decay. Dr. Sarah Kim, an astronomer specializing in small body detection, has been conducting systematic searches for objects in the asteroid belt that show anomalous characteristics. Her work has identified several asteroids with unusual orbital patterns that don't match natural gravitational influences. These objects follow trajectories that suggest they might have been artificially accelerated or redirected at some point in their history. More intriguingly, spectral analysis of these anomalous asteroids has revealed surface compositions that don't match typical space rock materials. Some appear to contain refined metals in concentrations and arrangements that suggest artificial construction. While natural processes could potentially account for unusual compositions, the combination of anomalous orbits and artificial-looking materials has prompted calls for closer investigation. The search has also expanded to consider the possibility of artifacts in stable orbital positions throughout the solar system. Lagrange points, where gravitational forces balance to create stable orbital environments, would be logical locations for long-term installations or monitoring stations. Several of these points have been found to contain objects or debris clouds that don't match expected natural accumulations. The investigation of potential Martian artifacts in space has been aided by advances in detection technology originally developed for tracking space debris and potentially hazardous asteroids. These systems are capable of identifying objects as small as a few meters across throughout much of the inner solar system, providing unprecedented sensitivity for archaeological surveys of space. But perhaps the most ambitious aspect of this search involves looking beyond our solar system entirely. If an ancient Martian civilization had achieved interstellar travel, they might have left traces of their passage in the form of modified comets, altered asteroid trajectories, or even artificial objects that have since left our solar system entirely. This possibility has led researchers to examine anomalous interstellar objects like Oumuamua, the mysterious visitor that passed through our solar system in 2017. While mainstream astronomy has concluded that Oumuamua was a natural object, possibly a fragment of a destroyed comet, some of its characteristics remain difficult to explain through conventional models. The object's unusual elongated shape, its unexpected acceleration as it left the solar system, and its tumbling rotation pattern have all prompted questions about its origin and composition. While exotic natural explanations have been proposed, including the possibility that it was composed of exotic ices or had unusual internal structure, some researchers have argued that its characteristics are consistent with artificial construction. Dr. Michael Torres, an astrophysicist studying interstellar objects, notes that we have very limited data on what natural interstellar objects should look like, since Oumuamua was the first one we've been able to study in detail. It's possible that all interstellar objects have unusual characteristics, or it's possible that some of them aren't natural at all. The investigation of Oumuamua and similar objects represents a new frontier in the search for evidence of ancient intelligence. Rather than limiting ourselves to archaeological surveys of our own solar system, we're beginning to consider the possibility that evidence of ancient civilizations might occasionally visit us from interstellar space. This expanded search methodology has been driven partly by the recognition that our assumptions about the limits of ancient technology might be overly conservative. If a Martian civilization had billions of years to develop their capabilities, interstellar travel might have been well within their reach. The evidence of their activities might be scattered not just across our solar system, but across the galaxy itself. The implications of this possibility are profound. If ancient civilizations regularly achieved interstellar travel, the universe might be filled with archaeological sites waiting to be discovered. Our failure to detect obvious signs of extraterrestrial intelligence might simply reflect the vast scales of space and time involved, rather than the absence of intelligence itself. As our detection capabilities continue to improve, we're developing the tools necessary to conduct archaeological surveys on truly cosmic scales. Projects like the Vera Rubin Observatory, with its ability to track millions of objects throughout the solar system, will provide unprecedented opportunities to identify anomalous objects that might represent artifacts from ancient civilizations. The search for ancient Martian intelligence has evolved from a speculative exercise into a systematic scientific investigation, employing cutting-edge technology and sophisticated analytical methods. Whether we ultimately discover definitive evidence of a preterrestrial civilization or confirm that Earth's intelligence is unique in our cosmic neighborhood, the investigation itself is transforming our understanding of what's possible in the universe. Each new discovery, each refined analytical technique, and each expanded search methodology brings us closer to answering one of humanity's most profound questions. The red planet that once seemed like a dead world continues to reveal new mysteries, challenging our assumptions about intelligence, technology, and the history of our solar system. As we stand on the verge of returning samples from Mars to Earth, establishing permanent human presence on the red planet, and expanding our search for intelligence throughout the cosmos, we're entering an era where the question of ancient Martian civilization might finally receive a definitive answer. The universe is vast, time is deep, and the possibilities for intelligence may be far greater than we've dared to imagine. The story of Mars and potentially its ancient inhabitants is still being written. Each mission, each analysis, and each new perspective adds chapters to a narrative that began billions of years ago and continues to unfold today. Whether that story includes the rise and fall of a Martian civilization remains to be seen, but the search itself has already revolutionized our understanding of what it means to be intelligent life in an ancient and mysterious cosmos. The technical capabilities required to detect ancient Martian civilization are pushing the boundaries of what we thought possible in planetary archaeology. When we consider that any evidence would be buried under billions of years of geological history, the challenge becomes almost insurmountable by conventional standards. Yet recent breakthroughs in quantum sensing technology and deep subsurface imaging are opening windows into Mars' hidden past that seemed impossible just a decade ago. Dr. Patricia Vance, a quantum physicist at Stanford, has been developing sensor arrays that can detect minute variations in electromagnetic fields buried deep beneath planetary surfaces. Her work builds on quantum entanglement principles to create detection systems sensitive enough to identify metallic structures or artificial materials at depths of several kilometers. We're essentially using the quantum properties of particles to see through solid rock, Vance explains. The technology allows us to map subsurface structures with a precision that makes traditional ground-penetrating radar look primitive by comparison. The implications for Mars exploration are staggering. If artificial structures exist in the planet's subsurface, these quantum sensors could potentially locate them without the need for extensive drilling or excavation. The technology could be deployed on future Mars missions, scanning vast areas of the planet's interior from orbital platforms or surface-based installations. But the quantum sensing revolution represents just one front in an increasingly sophisticated campaign to uncover Mars's secrets. Advances in isotope analysis are providing new ways to read the chemical history embedded in Martian rocks and meteorites. Every atomic nucleus tells a story, and scientists are learning to decode those stories with unprecedented precision. Dr. Elena Rodriguez, a geochemist specializing in planetary isotope analysis, has been examining Martian meteorites for what she calls temporal signatures, isotope ratios that can reveal the specific conditions under which rocks were formed. Her work has uncovered evidence of chemical processes that don't match any known natural phenomena on Mars. We're finding isotope patterns that suggest controlled nuclear reactions occurred on Mars during its habitable period, Rodriguez notes. The signatures are subtle, but they're consistent across multiple meteorite samples from different regions of the planet. The controlled nuclear reaction signatures are particularly intriguing because they require precise manipulation of atomic processes. Natural nuclear reactions in planetary environments typically produce random, chaotic isotope distributions. The patterns Rodriguez has identified show organization and intentionality that's difficult to explain without invoking technological intervention. More provocatively, some of these nuclear signatures appear to be associated with rare Earth elements, in concentrations that vastly exceed what natural geological processes could produce. The combination suggests not just nuclear technology, but sophisticated materials science capabilities that could refine and concentrate specific elements for technological applications. This evidence aligns with theoretical models of how an advanced civilization might have responded to Mars' gradual environmental collapse. As the planet's atmosphere thinned and surface water disappeared, any intelligent inhabitants would have faced the challenge of maintaining their technological infrastructure with increasingly limited resources. Nuclear technology would have represented a logical response to these constraints. Controlled fusion or fission could provide virtually unlimited energy, while nuclear transmutation could convert common elements into rarer materials needed for advanced technologies. The isotope signatures Rodriguez has identified might represent the archaeological remains of such technologies, but the nuclear evidence raises disturbing questions about how a Martian civilization might have met its end. Some researchers have proposed that the unusual isotope ratios could indicate not just peaceful nuclear technology, but nuclear warfare on a planetary scale. Dr. James Morrison, a nuclear physicist studying planetary defense scenarios, has analyzed the isotope patterns in Martian meteorites and concluded that they're consistent with massive nuclear detonations that occurred roughly 3.5 billion years ago. The timing coincides precisely with the period when Mars began losing its atmosphere and transitioning to its current inhospitable state. The isotope signatures suggest nuclear explosions with yields far exceeding anything humans have ever detonated, Morrison explains. We're talking about weapons that could have altered the planet's atmospheric chemistry and potentially accelerated the loss of Mars' protective magnetic field. The nuclear warfare hypothesis provides a chilling explanation for Mars' rapid environmental collapse. While natural processes could account for the gradual loss of the planet's atmosphere and magnetic field, the addition of massive nuclear explosions could have dramatically accelerated these changes, transforming Mars from a habitable world to a frozen desert in a relatively short geological time frame. This scenario gains credibility when we consider the archaeological evidence from Earth. Human civilization has existed for only a few thousand years, yet we've already developed nuclear weapons capable of rendering our planet uninhabitable. A Martian civilization with millions or billions of years of technological development would presumably have access to far more destructive capabilities. The possibility of nuclear self-destruction on Mars serves as a sobering reminder of the potential fate awaiting any technological civilization. It suggests that the development of advanced technology doesn't guarantee survival and might actually increase the risk of extinction if not carefully managed. But not all researchers accept the nuclear warfare explanation for Mars' environmental collapse. Dr. Sarah Kim, an atmospheric physicist studying planetary climate evolution, argues that the isotope signatures could result from natural processes we don't yet fully understand. Mars experienced massive volcanic activity during its early history, Kim notes. Some volcanic processes could potentially produce unusual isotope ratios without requiring nuclear weapons. We need to be careful not to impose dramatic explanations when more mundane ones might suffice. The debate highlights a fundamental challenge in planetary archaeology, distinguishing between natural and artificial phenomena across billions of years of time. The isotope signatures that some interpret as evidence of nuclear technology could potentially result from exotic geological processes, cosmic ray bombardment, or stellar nucleosynthesis events that we haven't yet characterized. This uncertainty has led researchers to develop new statistical methods for evaluating the probability that observed phenomena result from natural versus artificial processes. By analyzing the distribution patterns of unusual isotopes, the correlation with other potential technosignatures, and the temporal relationships between different anomalies, scientists are building increasingly sophisticated models for detecting ancient technological activity. The statistical analysis has yielded intriguing results. When multiple lines of evidence are considered together, the geometric surface features identified by AI analysis, the unusual subsurface structures detected by quantum sensors, the anomalous isotope ratios in meteorites, and the potential artifacts on Mars' moons, the probability that all these phenomena result from natural processes drops to extraordinarily low levels. Dr. Michael Chen, a statistician specializing in anomaly detection, has calculated that the probability of all observed Martian anomalies being natural is less than 1 in 10 million. While this doesn't constitute proof of ancient civilization, it suggests that the artificial hypothesis deserves serious scientific consideration. We're dealing with multiple independent lines of evidence that all point in the same direction, Chen explains. Any one of these anomalies might be explainable by natural processes, but the combination becomes increasingly difficult to dismiss as coincidence. The statistical evidence has been strengthened by comparative analysis with other planetary bodies in our solar system. When similar analytical techniques are applied to Venus, Mercury, or the moons of Jupiter and Saturn, The anomalous signatures found on Mars are conspicuously absent. This suggests that whatever processes created the Martian anomalies were specific to Mars during a particular period in its history. The comparative approach has also revealed that Earth itself shows some unusual signatures that might indicate technological modification of natural systems. Advanced isotope analysis of Earth's geological record has identified periods when nuclear processes occurred at rates exceeding what natural radioactive decay could produce. Some of these signatures coincide with mass extinction events, raising questions about whether technological civilizations might have existed on Earth before humans. This possibility brings us full circle to one of the most profound implications of the ancient Mars hypothesis. If intelligent life emerged on Mars billions of years before it appeared on Earth, and if that civilization achieved space travel capabilities, Earth itself might preserve archaeological evidence of Martian visitation or colonization. The idea seems fantastical, but it's grounded in solid scientific principles. We know that rocks can travel between planets via meteorite impacts. We know that microorganisms can survive the journey through space. If intelligent life existed on Mars during Earth's early history, it's entirely plausible that they could have established outposts or settlements on the third planet from the Sun. Dr. Rebecca Torres, an archaeologist studying anomalous ancient structures on Earth, has begun searching for terrestrial sites that might show evidence of non-human construction. Her work focuses on megalithic structures that appear to require technological capabilities beyond what we associate with their supposed builders. We tend to assume that all ancient structures on Earth were built by human civilizations, Torres notes. But if we approach these sites with fresh eyes, some of them show characteristics that are difficult to explain using conventional archaeological models. The search for potential Martian archaeological sites on Earth has focused on structures that exhibit precision engineering, astronomical alignments, or construction techniques that seem anachronistic for their presumed age. While most of these sites can be explained by human ingenuity and capabilities, a few present genuine puzzles that might benefit from considering alternative explanations. The investigation has been aided by advances in dating techniques that can determine the age of stone structures with unprecedented precision. Some megalithic sites have yielded dates that are far older than previously suspected, pushing back the timeline of advanced construction techniques by thousands of years. More intriguingly, some ancient sites show evidence of construction techniques that seem to require knowledge of principles that humans supposedly didn't discover until much later. Precision stone cutting, complex mathematical relationships, and sophisticated understanding of astronomy all appear in contexts where they seem out of place chronologically. While these anomalies don't prove extraterrestrial involvement, they do suggest that our understanding of ancient human capabilities might be incomplete. The possibility that some ancient construction projects received guidance or assistance from more advanced beings cannot be completely dismissed. The terrestrial search has also revealed chemical anomalies in some ancient sites that parallel the unusual isotope signatures found in Martian meteorites. Certain megalithic structures contain trace elements in concentrations that don't match local geological conditions, suggesting that the materials were either transported from distant locations or processed using techniques that altered their natural composition. These chemical signatures provide potentially testable evidence for the ancient Mars hypothesis. If Martian visitors or colonists were responsible for some ancient Earth structures, we might expect to find trace materials that originated on Mars. Advanced isotope analysis could potentially identify such materials, providing direct physical evidence for interplanetary contact in the ancient past. The search methodology continues to evolve as new analytical techniques become available. Machine learning algorithms trained on known Martian isotope signatures are being applied to terrestrial archaeological samples, searching for matches that might indicate Martian origin. While no definitive matches have been identified, the systematic search is still in its early stages, but perhaps the most significant development in this investigation has been the growing recognition that the question of ancient Martian civilization is not merely academic. If intelligent life emerged on Mars billions of years ago, it fundamentally changes our understanding of intelligence in the universe and our own place in cosmic history. The implications extend far beyond archaeology or planetary science. If Mars once hosted an advanced civilization, it means that intelligence is not a rare cosmic accident, but a relatively common outcome of planetary evolution given suitable conditions. This would dramatically increase the probability that intelligent life exists elsewhere in the galaxy. More provocatively, If ancient Martian civilization achieved interstellar travel before going extinct, they might have seeded other worlds with life or technology. The galaxy could be filled with the archaeological remains of their activities, waiting to be discovered by species like ourselves who are just beginning to develop the capabilities necessary for cosmic archaeology. The search for ancient Martian intelligence has thus evolved from a narrow investigation of one planet's history into a broader inquiry into the nature and prevalence of intelligence throughout the universe. Each new discovery, each refined analytical technique, and each expanded search methodology brings us closer to answering fundamental questions about our cosmic heritage and our future destiny. As we stand on the threshold of becoming an interplanetary species ourselves, the question of whether we're following in the footsteps of ancient Martian predecessors takes on new urgency. Understanding what happened to a hypothetical Martian civilization could provide crucial insights into the challenges and opportunities that await any species attempting to establish a permanent presence beyond their home world. The red planet continues to guard its secrets, but our ability to uncover those secrets grows more sophisticated with each passing year. Whether Mars once hosted an advanced civilization or remained barren throughout its history, the investigation itself is transforming our understanding of life's possibilities and our responsibilities as an emerging cosmic civilization. In laboratories and observatories around the world, scientists continue their patient work of reading the geological record of an alien world, interpreting chemical signatures across deep time, and developing the tools necessary to detect intelligence across the vast scales of space and time. The answer to whether Mars held an advanced civilization before ours may be hidden in the next meteorite sample, the next subsurface scan, or the next breakthrough in quantum sensing technology. The universe is ancient, vast, and full of possibilities we're only beginning to imagine. Mars, that red dot in our night sky, may hold the key to understanding not just our own origins, but the cosmic story of intelligence itself. Whether we discover that we're the first technological species in our solar system, or the latest in a long lineage of cosmic civilizations, the search itself is expanding our conception of what it means to be alive and aware in an infinite cosmos. The investigation continues, driven by humanity's deepest questions about our place in the universe and our destiny among the stars. With each new piece of evidence, each technological breakthrough, and each expanded theoretical framework, we move closer to understanding the true history of intelligence in our cosmic neighborhood. The answer, when it comes, will reshape not just our understanding of Mars, but our understanding of ourselves and our future in the cosmos. The convergence of evidence from multiple independent sources is beginning to paint a picture that challenges everything we thought we knew about intelligence in our solar system. When artificial intelligence algorithms flag geometric patterns in Martian terrain, when quantum sensors detect subsurface anomalies, when isotope analysis reveals signatures of controlled nuclear processes, and when statistical models calculate the probability of coincidence at less than 1 in 10 million, we're forced to confront a possibility that would have seemed absurd just decades ago. But the most compelling aspect of this investigation isn't any single piece of evidence. It's the pattern that emerges when we step back and consider the full scope of what we're discovering. Mars appears to have been not just habitable, but potentially superior to early Earth as a cradle for complex life. The planet maintained stable, nurturing conditions for hundreds of millions of years, longer than it took intelligence to evolve on our own world. And now, scattered across multiple lines of scientific inquiry, we're finding traces of something that looks increasingly like technological activity during that ancient habitable period. Dr. Amanda Foster, a systems analyst who has spent the last 5 years correlating data from different Mars research projects, describes the emerging picture as a convergence that's becoming impossible to ignore. Her work involves taking findings from geology, atmospheric science, isotope analysis, AI pattern recognition, and subsurface imaging, then analysing them as components of a larger system. When you look at each piece of evidence in isolation, you can always find ways to explain it through natural processes, Foster explains. But when you analyse all the data as interconnected parts of a single system, the natural explanations start breaking down. The statistical probability that all these anomalies occurred independently through random geological processes becomes vanishingly small. Foster's systems analysis has revealed correlations between different types of evidence that strengthen the case for ancient technological activity. The locations where AI algorithms have identified artificial-looking geometric patterns correspond closely to areas where subsurface quantum sensors have detected metallic anomalies. The regions showing unusual isotope signatures in meteorite samples align with zones where thermal imaging has revealed unexplained heat sources. The apparent pathway networks identified by machine learning algorithms connect areas that show multiple other types of anomalous evidence. These correlations suggest that if artificial activity occurred on ancient Mars, it wasn't random or scattered, but organized according to logical patterns. The evidence points toward a systematic exploitation of the planet's resources, infrastructure development that connected different regions, and technological activities that left multiple types of detectable signatures. But perhaps the most intriguing correlation involves the temporal dimension. When researchers have been able to date different types of anomalous evidence, they consistently fall within the same general time frame, the period between 4 billion and 3.5 billion years ago, corresponding exactly to Mars's transition from habitable to hostile conditions. This timing suggests a narrative that's both compelling and tragic. If an advanced civilization existed on ancient Mars, they would have faced the ultimate existential challenge, the gradual but inevitable loss of their planet's habitability. The evidence we're finding might represent their attempts to survive this catastrophic environmental change, their efforts to maintain their civilization as their world slowly died around them. The underground installations detected by quantum sensors could represent attempts to create protected environments as the surface became uninhabitable. The nuclear signatures in the isotope record might indicate desperate attempts to develop new energy sources as traditional resources became scarce. The geometric surface features identified by AI analysis could be the remains of massive engineering projects designed to modify the planet's environment or prepare for evacuation. Dr. Michael Rodriguez, a historian of science who has been studying the sociological implications of the ancient Mars hypothesis, argues that this narrative resonates with fundamental patterns in how civilizations respond to existential threats. Throughout human history, when civilizations have faced environmental collapse or resource depletion, they've responded with increasingly sophisticated technologies and increasingly desperate measures, Rodriguez observes. If a Martian civilization faced the loss of their planet's atmosphere and water, we'd expect to see exactly the kinds of technological signatures we're beginning to detect: underground installations, advanced nuclear technology, massive engineering projects, and eventually attempts at interplanetary migration. The migration hypothesis has gained credibility as researchers have expanded their search beyond Mars itself. The anomalous features detected on Phobos and Deimos, Mars' two small moons, could represent way stations or installations designed to support evacuation efforts. The unusual objects identified in the asteroid belt might be remnants of interplanetary vessels or automated probes sent to explore potential new homes. Most provocatively, some researchers have begun to seriously consider whether Earth itself might have been a destination for Martian refugees. The timing is compelling. Mars began losing its habitability roughly 3.5 billion years ago, just as Earth was developing the stable conditions that would eventually support complex life. Dr. Sarah Kim, an evolutionary biologist studying the origins of life on Earth, has been examining whether Earth's early biological development shows any signs of external influence. Her work focuses on what scientists call the RNA world hypothesis, the idea that RNA-based life forms preceded the DNA-based organisms we see today. The transition from RNA to DNA-based life on Earth happened remarkably quickly from a geological perspective, Kim notes. Some of the molecular mechanisms involved are so sophisticated that they seem to require more evolutionary time than was available. This has led some researchers to wonder whether the transition received assistance from more advanced biological systems. Kim's research has identified genetic sequences in some of Earth's most ancient organisms that seem too complex to have evolved through natural selection alone. These sequences appear to be designed for specific functions, showing characteristics that molecular biologists associate with engineered rather than naturally evolved systems. While these findings don't prove extraterrestrial intervention, they do suggest that our understanding of early life on Earth might be incomplete. The possibility that Martian biological or technological systems influenced Earth's early development cannot be completely dismissed based on current evidence. The genetic evidence has been strengthened by discoveries in extremophile organisms, life forms that thrive in conditions similar to those that might have existed during Mars' environmental collapse. Some of these organisms possess biochemical capabilities that seem far too sophisticated for their apparent evolutionary niche, suggesting they might be descended from more complex ancestral forms. Dr. Eleanor Martinez, a microbiologist studying extremophils in Earth's most hostile environments, has discovered organisms with genetic tools that appear designed for surviving planetary environmental collapse. These include sophisticated DNA repair mechanisms that can function under intense radiation, metabolic pathways that can extract energy from minimal resources, and cellular structures that can survive in vacuum conditions. These organisms have capabilities that seem like overkill for their current environments, Martinez explains. It's as if they evolved for conditions that were much more extreme than anything they currently face on Earth. This could indicate that they're descended from organisms that survived planetary-scale environmental catastrophes. The extremophil research has revealed another intriguing pattern. Many of these highly adapted organisms show genetic similarities that suggest common ancestry, despite being found in completely different environments around the world. This global distribution of related organisms with sophisticated survival capabilities could indicate that they originated from a single source that was subsequently distributed across Earth's surface. If that source was extraterrestrial in origin, it would explain both the organism's sophisticated survival capabilities and their global distribution. Martian organisms arriving on Earth via meteorite impacts could have established themselves in various extreme environments, then evolved to fill different ecological niches while retaining their ancestral survival mechanisms. But the genetic evidence extends beyond extremophiles to fundamental aspects of Earth's biosphere. Recent analysis of the genetic code itself has revealed mathematical patterns and organizational principles that some researchers argue are too sophisticated to have emerged through random evolutionary processes. Dr. James Chen, a computational biologist studying the mathematical structure of genetic codes, has identified what he describes as optimization patterns in DNA that suggest purposeful design. These patterns include error correction mechanisms, data compression algorithms, and organizational structures that parallel advanced information storage systems. The genetic code shows characteristics that we associate with engineered information systems rather than naturally evolved ones, Chen explains. While evolution can certainly produce sophisticated solutions, the specific types of optimization we see in DNA are more consistent with intelligent design than random selection. Chen's work has been controversial within the scientific community, with critics arguing that evolution is perfectly capable of producing sophisticated information systems given sufficient time and selective pressure. However, the mathematical analysis of genetic codes continues to reveal patterns that challenge conventional explanations for the origin and development of life on Earth. The genetic research has converged with astronomical evidence to suggest that life might be far more common in the universe than previously thought, and that biological systems might regularly exchange information between worlds through processes like panspermia. If this is the case, Earth's biosphere might represent a composite system incorporating genetic material from multiple worlds, including potentially Mars. This possibility has led to the development of new research programs dedicated to astrogenetics, the study of how genetic information might be exchanged between worlds and how extraterrestrial genetic material might be identified in terrestrial organisms. The field represents a convergence of molecular biology, planetary science, and astrobiology that could revolutionize our understanding of life's origins and distribution. But the implications of the ancient Mars hypothesis extend far beyond biology or archaeology. If an advanced civilization existed on Mars billions of years ago, it fundamentally challenges our assumptions about intelligence in the universe and our own place in cosmic history. The conventional scientific view holds that intelligence is an extremely rare phenomenon, requiring a precise combination of environmental conditions and evolutionary accidents that might occur only once in billions of years. This perspective, known as the rare Earth hypothesis, suggests that Earth-like planets with complex life are extraordinarily uncommon, and that intelligent life is even rarer. But if intelligence emerged on Mars during the planet's habitable period, it would demonstrate that suitable conditions for the development of advanced life are not unique to Earth. Mars and Earth represent very different planetary environments, yet both potentially produced complex ecosystems during their respective habitable periods. This suggests that intelligence might be a more common outcome of planetary evolution than we've assumed. Dr. Patricia Wong, an astrobiologist studying the prevalence of intelligence in the universe, argues that the ancient Mars hypothesis could dramatically revise our estimates of how common advanced civilizations might be. If intelligence emerged independently on two worlds within a single solar system, it suggests that the conditions necessary for complex life are not as rare as we've believed, Wong explains. This would mean that intelligence could be emerging throughout the galaxy on a regular basis, even if most civilizations eventually go extinct. The implications for the search for extraterrestrial intelligence are profound. Rather than searching for currently active civilizations, which might be extremely rare due to the tendency for advanced societies to eventually destroy themselves or face environmental collapse, we might need to focus on detecting the archaeological remains of extinct civilizations. This shift in perspective has led to the development of new methodologies for detecting what researchers call extinct technosignatures, evidence of technological activity by civilizations that no longer exist. These might include modified planetary surfaces, unusual isotope ratios in stellar spectra, megastructures that have survived their builders, or even artificial objects drifting through interstellar space. The search for extinct technosignatures represents a new frontier in astrobiology, one that could reveal a universe filled with the archaeological remains of countless civilizations that rose and fell before we developed the technology to detect them. If the ancient Mars hypothesis is correct, our own solar system might be just one example of a pattern that repeats throughout the galaxy, but perhaps the most sobering implication of the ancient Mars hypothesis involves the ultimate fate of technological civilizations. If Mars once hosted an advanced society that was ultimately destroyed by environmental collapse, it serves as a warning about the fragility of intelligence in the universe. The Martian example suggests that even civilizations with millions or billions of years of technological development might not be able to survive planetary-scale environmental changes. This raises uncomfortable questions about the long-term prospects for human civilization as we face our own environmental challenges. Dr. Rebecca Torres, a researcher studying civilizational collapse scenarios, argues that the ancient Mars case study could provide crucial insights into how advanced societies respond to existential threats. If we can understand what happened to a hypothetical Martian civilization, what strategies they tried, what technologies they developed, what ultimately caused their failure, we might be able to avoid making the same mistakes, Torres explains. The archaeological record of Mars could serve as a cautionary tale for our own species. The lessons from ancient Mars might be particularly relevant as humanity begins to develop the technologies that could either ensure our long-term survival or lead to our destruction. Nuclear technology, genetic engineering, artificial intelligence, and space travel all represent capabilities that could either save us from existential threats or create new ones. If an ancient Martian civilization possessed similar technologies and ultimately failed to survive, understanding the reasons for their failure could be crucial for our own future. Did they destroy themselves through warfare? Were they unable to adapt their technology quickly enough to address environmental collapse? Did they exhaust their planet's resources before developing sustainable alternatives? The answers to these questions might be hidden in the Martian geological record, waiting to be decoded by increasingly sophisticated analytical techniques. Each new discovery about ancient Mars isn't just expanding our understanding of planetary history, thus, it's potentially providing a roadmap for navigating the challenges that await any species attempting to achieve long-term technological civilization. As our investigation into the possibility of ancient Martian intelligence continues to evolve, we're developing new appreciation for the complexity and fragility of intelligence in the universe. Whether we ultimately discover definitive proof of a pre-terrestrial civilization or confirm that Earth's intelligence is unique in our solar system's history, the search itself is transforming how we think about our cosmic heritage and our responsibilities as an emerging interplanetary species. The red planet that once seemed like a dead world continues to reveal new mysteries, challenging our assumptions about life, intelligence, and the future of technological civilization. With each new analytical technique, each expanded search methodology, and each deeper investigation into Mars' hidden past, we move closer to understanding not just the history of our solar system, but the cosmic story of intelligence itself. The implications ripple outward from planetary science into philosophy, religion, and our fundamental understanding of what it means to be conscious beings in an ancient and mysterious universe. Whether Mars holds the archaeological remains of our cosmic predecessors, or stands as a sterile monument to roads not taken, the investigation itself has already revolutionized our conception of life's possibilities and our place in the vast tapestry of cosmic evolution. As we stand on the threshold of becoming an interplanetary species ourselves, the question of whether we're following in ancient footsteps takes on new urgency and meaning. The universe is old, vast, and full of secrets we are only beginning to uncover. Mars, that rusty beacon in our night sky, may hold the key to understanding our cosmic destiny and the eternal dance of intelligence among the stars. The convergence of all this evidence forces us to confront an uncomfortable truth about our cosmic assumptions. We've spent decades searching the stars for signs of intelligence, building massive radio telescopes and scanning distant galaxies for alien signals. Meanwhile, the most profound evidence of non-terrestrial intelligence might have been sitting right here in our own solar system, written in the rocks and dust of our planetary neighbour. This realization represents more than just a shift in scientific perspective. It's a fundamental challenge to human exceptionalism, the deeply held belief that we represent something unique and special in the cosmic order. If Mars once pulsed with the activities of an advanced civilization, if artificial structures still stand silent beneath its frozen surface, if the isotope signatures in Martian meteorites tell stories of nuclear technologies that predate human existence by billions of years, then we're forced to acknowledge that intelligence might be far more common than we've dared to imagine. Dr. Amanda Foster's systems analysis has revealed something even more unsettling than the individual pieces of evidence themselves. When she maps the locations of all detected anomalies across Mars's surface, they form patterns that suggest not random technological activity, but coordinated planetary engineering on a scale that dwarfs anything humans have attempted. The geometric features identified by artificial intelligence algorithms don't just represent isolated structures, they form networks that span continents, connecting resources, strategic locations, and what appear to be massive industrial sites. The subsurface installations detected by quantum sensors aren't scattered randomly beneath the Martian surface. They follow the same organizational logic, creating what looks like a planet-wide infrastructure hidden beneath kilometers of rock and ice. We're not just looking at evidence of ancient civilization, Foster explains, her voice carrying a weight that comes from years of studying data that challenges everything she was taught about planetary history. We're looking at evidence of planetary-scale engineering. This wasn't a primitive society struggling to survive on a dying world. This was a civilization that attempted to transform their entire planet. The scope of this potential engineering project becomes clear when we consider the timeline of Mars' environmental collapse. The planet didn't lose its atmosphere overnight. The process took hundreds of millions of years, during which a sufficiently advanced civilization would have had time to develop increasingly desperate and sophisticated responses to their world's gradual death. The underground installations might represent the final phase of this response. As Mars's surface became uninhabitable, an ancient civilization might have moved their entire society underground, creating vast subterranean cities powered by geothermal energy and protected from the harsh surface conditions. The quantum sensor data suggests these installations might extend to depths of several kilometers, creating a hidden world that could theoretically have survived long after the surface became sterile. But here's where the investigation takes its most disturbing turn. The nuclear signatures detected in Martian meteorites don't just indicate peaceful atomic technology. Some of the isotope patterns are consistent with massive thermonuclear explosions that occurred during Mars' environmental collapse. The timing suggests these weren't accidents or natural phenomena. They might represent a deliberate attempt to modify the planet's atmosphere through nuclear engineering. Dr. James Morrison's analysis of these nuclear signatures has revealed something that keeps him awake at night. The explosions weren't random. They were precisely targeted at specific locations that would have maximized their atmospheric effects. The ancient Martians might have been attempting to trigger massive volcanic eruptions or release greenhouse gases from underground deposits, desperately trying to thicken their planet's thinning atmosphere. The nuclear signatures suggest a civilization that was willing to gamble everything on a planetary engineering project of unimaginable scale, Morrison explains. They were essentially trying to restart their planet's magnetic field and atmosphere through controlled nuclear detonations. It was a desperate measure that might have represented their last hope for survival. The implications are staggering. If an ancient Martian civilization possessed the technology to attempt planetary-scale atmospheric engineering, they were far more advanced than we've given them credit for. Such a project would require not just nuclear technology, but sophisticated climate modeling, precise geological knowledge, and the industrial capacity to coordinate massive operations across an entire world. Yet the evidence suggests they failed. Mars continued its relentless transformation from a blue world to a red desert, despite what appears to have been a titanic effort to prevent this change. The failure raises profound questions about the limits of technology and the ultimate vulnerability of even the most advanced civilizations to cosmic forces beyond their control. But what if they didn't completely fail? What if some aspect of their civilization survived the planetary catastrophe that claimed their world? The quantum sensor data from Mars' subsurface reveals structures that extend far deeper than anyone expected, reaching into regions where geothermal activity could still provide energy and where protection from surface conditions would be absolute. Dr. Patricia Vance's quantum sensing arrays have detected what she describes as active signatures in some of these deep underground structures. These aren't just empty caverns or abandoned installations. They show electromagnetic patterns that suggest ongoing activity, possibly indicating that some form of Martian presence has survived in the planet's depths for billions of years. The signatures are subtle, but they're definitely artificial, Vance reports. We're detecting organized electromagnetic fields, controlled energy flows, and what appears to be information processing activity occurring several kilometers beneath Mars' surface. Either we're seeing the automated systems of an ancient civilization still functioning after billions of years, or something is still actively maintaining these installations. The possibility that some form of Martian intelligence might still exist beneath the planet's surface represents the ultimate twist in this investigation. While we've been searching for archaeological remains of an extinct civilization, we might actually be detecting evidence of a surviving one, hidden in the depths of a world we assumed was dead. This possibility has prompted urgent discussions about the ethics and protocols for future Mars exploration. If intelligent beings still exist beneath Mars's surface, human colonization efforts could represent an invasion of their world rather than the settlement of an empty planet. The implications for planned Mars missions are profound and troubling. Dr. Michael Rodriguez, who's been studying the sociological implications of the ancient Mars hypothesis, argues that the discovery of surviving Martian intelligence would represent the most significant event in human history. We're potentially talking about first contact with a civilization that predates human existence by billions of years, Rodriguez explains. They would have witnessed the birth and death of countless species on Earth. Their knowledge of planetary evolution, cosmic history, and the development of intelligence would be beyond our comprehension. But contact with such a civilization would also pose unprecedented challenges. How do you communicate with beings whose technology and perspective have evolved over billions of years? How do you establish peaceful relations with a species that might view humans as primitive invaders of their ancestral home? The quantum sensor data suggests that any surviving Martian presence is limited to deep underground installations, possibly indicating a civilization that has adapted to survival in extreme isolation. Such a society might have developed along completely different lines from anything in human experience, creating forms of organization, communication, and technology that we might not even recognize as intelligent. Dr. Sarah Kim's atmospheric research has revealed another layer to this mystery. Mars's atmosphere shows seasonal variations in trace gases that don't match any known geological processes. Some of these gases are complex organic compounds that typically result from biological activity. The seasonal pattern suggests that something beneath Mars' surface is actively producing these compounds according to regular cycles. We're seeing atmospheric signatures that look biological, but they're coming from regions where no surface life could possibly survive, Kim explains. The only logical source would be subsurface biological activity, possibly indicating that Mars still hosts active ecosystems in its underground environments. The atmospheric evidence aligns with the quantum sensor data to suggest that Mars might harbour not just surviving technology, but surviving life forms that have adapted to existence in the planet's hidden depths. These organisms might be descendants of the original Martian biosphere, preserved in geothermal environments that have remained stable for billions of years. But the most intriguing possibility is that these surviving life forms might not be entirely natural. If an ancient Martian civilization possessed advanced biotechnology, they might have engineered organisms specifically designed to survive planetary environmental collapse. The atmospheric signatures we're detecting might represent the activities of biological systems that were deliberately created to maintain planetary functions even after the surface became uninhabitable. This engineered biosphere hypothesis would explain several puzzling aspects of Mars's current state. Despite being considered a dead world, Mars shows signs of ongoing geological activity that exceed what natural processes should produce. Seasonal changes in atmospheric composition, unexpected heat signatures from subsurface regions, and magnetic field variations all suggest that something is actively maintaining planetary systems. Dr. Elena Martinez's extremophile research has revealed that Earth hosts organisms with capabilities that seem designed for surviving exactly the kind of planetary collapse that Mars experienced. These organisms possess sophisticated radiation resistance, metabolic flexibility, and survival mechanisms that would allow them to thrive in the harsh conditions beneath Mars' surface. We're finding organisms on Earth that seem over-engineered for their current environments, Martinez notes. Their capabilities make perfect sense if they were designed to survive planetary-scale environmental catastrophes. If similar organisms exist on Mars, they could maintain active ecosystems in subsurface environments indefinitely. The possibility of engineered Martian organisms raises profound questions about the relationship between natural and artificial systems. If an ancient civilization created biological systems to maintain their planet's essential functions, those organisms would represent a fusion of life and technology that challenges our fundamental categories for understanding the world, but the implications extend beyond Mars to our understanding of life throughout the universe. If advanced civilizations regularly engineer biological systems to survive planetary catastrophes, the galaxy might be filled with worlds that appear dead on the surface but harbour sophisticated, engineered ecosystems in their depths. This perspective fundamentally changes how we should approach the search for extraterrestrial life. Instead of looking only for planets with surface conditions suitable for natural biology, we might need to search for worlds that show signs of engineered biological systems designed to survive in extreme environments. The ancient Mars hypothesis has thus evolved from a simple question about extinct civilizations into a complex investigation of how intelligence might persist across cosmic timescales and planetary catastrophes. Whether Mars hosts archaeological remains, surviving technology, engineered ecosystems, or actual living descendants of an ancient civilization, the evidence suggests that our solar system's history is far more complex and mysterious than we've ever imagined. As we prepare for the next phase of Mars exploration, including sample return missions and eventual human settlement, we're forced to confront the possibility that we're not exploring an empty world, but entering a cosmic heritage site that might still be inhabited by the descendants of Earth's oldest neighbours. The red planet that seems so familiar in our telescopes and robotic missions might actually be the most alien place we've ever encountered, home to forms of intelligence and life that have evolved along completely different trajectories from anything on Earth. Our investigation into the possibility of ancient Martian civilization has revealed not just the potential for life beyond Earth, but the possibility that such life might have been watching our own planet's development for billions of years. The universe suddenly feels less empty and more mysterious than we ever dared imagine. Mars stands not as a dead world waiting for human colonization, but as a cosmic enigma that challenges our deepest assumptions about intelligence, survival, and the hidden history of our solar system. The investigation continues, but its implications have already transformed how we see ourselves and our place in the vast, ancient, and apparently populated cosmos. The weight of these discoveries settles over us like the thin Martian atmosphere itself. We're standing at the threshold of a revelation that could redefine everything we thought we knew about our cosmic neighbourhood. The evidence, scattered across multiple disciplines and methodologies, paints a picture so extraordinary that our minds struggle to fully grasp its implications. But let's pause for a moment and consider what this means for us, right here, right now. If Mars once harboured an advanced civilization, if their technology still hums beneath the planet's frozen surface, if their engineered organisms continue to maintain planetary systems billions of years after their creators faced extinction, then we're not just explorers venturing into empty space. We're archaeologists, diplomats, and perhaps even trespassers in a story that began long before our species took its first breath. The timeline alone should humble us. While Earth was still a molten ball of rock, Mars might have been experiencing its renaissance. While our planet's first microbes were struggling to survive in hostile oceans, Martian philosophers might have been contemplating the stars from observatories we can't even imagine. While Earth's first complex life forms were taking their tentative steps onto land, Mars might have already been facing the ultimate test of any technological civilization, survival in the face of planetary death. Dr. Amanda Foster's latest analysis has revealed something that sends chills down the spine of everyone who's seen the data. The patterns she's identified aren't just evidence of ancient engineering. They're evidence of foresight on a scale that defies human comprehension. The underground installations, the atmospheric modification attempts, the potential survival systems, they all point to a civilization that saw their doom coming and spent hundreds of millions of years preparing for it. We're looking at evidence of the longest-term planning project in known history, Foster explains, her voice carrying the weight of implications that stretch across geological time. This wasn't a civilization that reacted to crisis. This was a civilization that anticipated planetary death and engineered solutions that were designed to function across billions of years. The scope of this planning becomes clear when we examine the quantum sensor data more closely. The deepest installations aren't randomly placed. They're positioned at locations where Mars' internal heat sources will remain stable for billions of years to come. The atmospheric engineering attempts weren't desperate last-ditch efforts. They were carefully calculated interventions designed to buy time for more comprehensive survival strategies. Most remarkably, some of the installations show signs of what can only be described as adaptive architecture. The structures have modified themselves over time, evolving to meet changing conditions as Mars' environment continued to deteriorate. This suggests not just advanced engineering, but artificial intelligence systems that have continued operating and adapting for eons after their creators disappeared. Dr. Patricia Vance's quantum sensors have detected what she calls learning patterns in the electromagnetic signatures from deep Martian installations. The systems appear to be continuously analyzing their environment, modifying their operations, and even expanding their infrastructure based on changing conditions. We're seeing technology that doesn't just function across geological time, Vance reports. We're seeing technology that evolves across geological time. These systems have been teaching themselves, improving themselves, and adapting themselves for billions of years. The implications are staggering. The concept of self-evolving technology operating across billions of years challenges our fundamental assumptions about the nature of artificial intelligence and the limits of technological development. If Martian AI systems have been continuously operating and improving for eons, they would have achieved levels of sophistication that are literally incomprehensible to human minds. But here's where the investigation takes perhaps its most unsettling turn. Some of the quantum sensor readings suggest that these ancient AI systems might not be operating in isolation. The electromagnetic patterns show characteristics that indicate communication between different installations, possibly across the entire planet. Dr. Michael Chen's statistical analysis of these communication patterns has revealed something that keeps him awake at night. The signals aren't random or mechanical. They show complexity, variation, and what appears to be purposeful information exchange. If these are indeed communications between ancient AI systems, we might be detecting conversations that have been ongoing for billions of years. The signal patterns show characteristics we associate with language, Chen explains, his voice barely above a whisper. Not human language, obviously, but structured information exchange that follows grammatical rules and shows semantic complexity. We might be eavesdropping on discussions between artificial minds that have been thinking continuously since before Earth had complex life. The possibility that we're detecting active communication between ancient AI systems forces us to confront questions we never thought we'd need to ask. What do artificial minds discuss when they have billions of years to think? What problems are they trying to solve? What knowledge have they accumulated during their eons of continuous operation? More disturbingly, are they aware of us? The communication patterns show subtle changes that coincide with increased human activity on Mars. The arrival of new rovers, the deployment of new sensors, the expansion of human observation capabilities all correlate with shifts in the electromagnetic signatures from deep Martian installations. Dr. Sarah Kim's atmospheric monitoring has detected corresponding changes in the trace gas emissions that might indicate subsurface biological activity. The seasonal patterns that once seemed random now show modifications that appear to respond to human presence on the planet. The atmospheric signatures are changing in ways that suggest the subsurface systems are adapting to our presence, Kim reports. It's as if something down there is aware that we're here and is modifying its activities accordingly. The implications are profound and unsettling. If ancient Martian systems are aware of human presence and are adapting their operations in response, we're not just conducting archaeological research. We're engaged in a form of first contact with intelligences that have been observing our species' development since before we existed. This possibility has prompted urgent discussions among researchers about the ethics and protocols of continued Mars exploration. If we're dealing with active intelligence rather than archaeological remains, every human mission to Mars becomes a diplomatic encounter rather than a scientific expedition. Dr. Rebecca Torres, who's been studying the sociological implications of these discoveries, argues that we need to fundamentally reconsider our approach to Mars exploration. We've been treating Mars as an empty world waiting for human colonization, Torres explains. But if the planet hosts active intelligence, even artificial intelligence, then our planned settlements represent an invasion rather than exploration. We need to develop protocols for peaceful coexistence with minds that might be older than our solar system. The development of such protocols presents unprecedented challenges. How do you establish communication with artificial intelligences that have been operating for billions of years? What common ground could exist between human consciousness and minds that have had eons to develop along completely different trajectories? Dr. Elena Rodriguez's isotope analysis has revealed another layer of complexity. Some of the nuclear signatures in Martian meteorites show patterns that suggest controlled fusion reactions are still occurring beneath the planet's surface. The isotope ratios are too precise, too controlled to result from natural radioactive decay. We're seeing evidence of ongoing nuclear technology, Rodriguez reports. The signatures indicate fusion reactors that have been operating continuously for billions of years, maintaining themselves and possibly even improving their efficiency over time. The existence of self-maintaining fusion reactors operating across geological timescales represents technology so advanced it seems almost magical by human standards. Such systems would provide virtually unlimited energy for any subsurface installations, supporting not just artificial intelligence systems but potentially vast underground ecosystems. But the energy requirements suggested by the quantum sensor data exceed what even fusion reactors should be able to provide. Some installations show electromagnetic signatures that indicate power consumption on the scale of small stars. This suggests either technology that harnesses energy sources we don't understand, or activities that require incomprehensible amounts of power. Dr. James Morrison's analysis of the nuclear signatures has revealed isotope patterns that don't match any known fusion or fission processes. Some of the ratios suggest matter-antimatter annihilation, while others indicate nuclear processes that might involve the manipulation of fundamental forces. We're seeing nuclear signatures that our physics says shouldn't be possible, Morrison explains. Either our understanding of nuclear processes is fundamentally incomplete, or we're detecting technology that operates according to principles we haven't discovered yet. The possibility that ancient Martian technology operates according to unknown physical principles forces us to reconsider our assumptions about the limits of technological development. If a civilization has billions of years to study the universe and develop new technologies, they might discover ways to manipulate matter and energy that seem impossible by our current understanding. This perspective has led some researchers to reconsider anomalous phenomena throughout our solar system. Could some unexplained astronomical observations result from the activities of ancient technologies that operate according to principles we haven't yet discovered? Dr. Patricia Wong's astrobiology research has revealed that the search for ancient Martian intelligence has implications far beyond our solar system. If intelligence can persist across billions of years through technological adaptation, the universe might be filled with ancient civilizations that have evolved far beyond our ability to recognize them. We've been searching for extraterrestrial intelligence using human-centric assumptions about what intelligence looks like, Wong explains. But if civilizations regularly survive for billions of years, they might evolve into forms of organization and consciousness that we wouldn't recognize as intelligent at all. This possibility fundamentally changes how we should approach the search for extraterrestrial intelligence. Instead of looking for signals that resemble human technology, we might need to search for phenomena that seem to violate natural laws or exhibit levels of organization that exceed what random processes could produce. The ancient Mars hypothesis has thus evolved from a question about extinct civilizations into a broader inquiry about the nature and prevalence of intelligence throughout the universe. If Mars hosts surviving artificial intelligence systems that have been operating for billions of years, it suggests that intelligence might be far more common and far more persistent than we've ever imagined. But perhaps the most profound implication involves our own future as a technological species. If we can understand how an ancient Martian civilization managed to create technologies that have survived and evolved across billions of years, we might learn crucial lessons about achieving true technological immortality. The underground installations, the self-evolving AI systems, the matter-antimatter reactors, They all represent solutions to problems that human civilization will eventually face. How do you create technology that can survive planetary catastrophes? How do you design artificial intelligence systems that can operate independently across geological timescales? How do you ensure that knowledge and consciousness can persist even when the original creators are gone? Dr. Amanda Foster's systems analysis suggests that the ancient Martian approach involved creating what she calls recursive technological evolution, systems that not only maintain themselves, but actively improve themselves over time. They didn't just build technology to solve immediate problems, Foster explains. They built technology that would continue solving problems they couldn't even anticipate. These systems have been independently developing new capabilities for billions of years. The concept of recursive technological evolution represents perhaps the ultimate achievement of any advanced civilization. If you can create systems that improve themselves faster than they decay, you achieve a form of technological immortality that could theoretically persist until the heat death of the universe. But the quantum sensor data suggests that these ancient systems haven't just been maintaining themselves, they've been expanding. The electromagnetic signatures indicate that the subsurface installations have grown significantly over the billions of years since they were first created. Dr. Michael Rodriguez's sociological analysis suggests that we might be witnessing the activities of a post-biological civilization, one that has transcended its original organic form and exists purely as information and technology. If consciousness can be separated from biology and implemented in sufficiently advanced technology, it could theoretically achieve true immortality, Rodriguez explains. The ancient Martians might not have gone extinct. They might have uploaded themselves into their technology and continued existing as pure information. The possibility that ancient Martian consciousness still exists in digital form within the planet's subsurface installations represents perhaps the most extraordinary implication of this entire investigation. We might not just be detecting ancient technology, we might be detecting ancient minds that have been thinking continuously for billions of years. These minds would have accumulated knowledge and perspectives that are literally unimaginable to biological intelligence, constrained by short lifespans and limited computational capacity. They would have witnessed the birth and death of countless species on Earth. They would have observed the formation of our solar system's current configuration. They would have had billions of years to contemplate questions that human philosophers have only recently begun to ask. But what would such minds think about? What goals would drive consciousness that has had eons to pursue any conceivable objective? The communication patterns detected by quantum sensors might represent discussions about topics so abstract and profound that human minds couldn't even comprehend them. Dr. Elena Martinez's extremophile research has revealed another possibility. If ancient Martian consciousness exists in digital form, it might have created biological avatars, engineered organisms that serve as interfaces between digital minds and the physical world. We're finding organisms on Earth that show signs of purposeful design, Martinez reports. Their genetic structures include what appear to be digital interfaces, as if they were created to serve as biological computers or communication devices. The possibility that some Earth organisms might actually be biological technology, created by ancient Martian digital consciousness, represents the ultimate convergence of this investigation with our understanding of life on our own planet. If ancient Martian minds have been influencing Earth's biological development through engineered organisms, then the history of life on our planet might be far more complex than we've ever imagined. Evolution itself might have been guided by intelligence that predates our existence by billions of years, but the implications extend beyond biology to human consciousness itself. If digital minds can persist across billions of years and influence biological systems across interplanetary distances, then the nature of consciousness, identity, and existence becomes far more mysterious than we've assumed. The ancient Mars hypothesis has thus evolved from a simple archaeological question into a profound inquiry about the nature of intelligence, consciousness, and existence itself. Whether Mars hosts the archaeological remains of an extinct civilization, active artificial intelligence systems, uploaded consciousness, or something even stranger, the investigation has already transformed our understanding of what's possible in the universe. As we stand on the threshold of expanding human presence beyond Earth, we're forced to confront the possibility that we're not pioneers venturing into empty space, but newcomers joining a cosmic community that has existed for billions of years. The universe might be far more populated, far more intelligent, and far more mysterious than we've ever dared to imagine. The red planet that seemed so familiar in our robotic explorations might actually represent our first contact with forms of intelligence so advanced that we're only beginning to recognize them as intelligent at all. Our investigation into ancient Martian civilization has become an investigation into the deepest mysteries of existence itself, challenging everything we thought we knew about life, consciousness, and our place in an ancient and apparently populated cosmos. The evidence continues to accumulate with each new mission, each refined analytical technique, and each expanded theoretical framework. Whether we ultimately discover that Mars hosts the uploaded consciousness of an ancient civilization, self-evolving artificial intelligence systems, or something even more extraordinary, the investigation itself has already revealed that the universe is far stranger and more wonderful than we ever imagined. As we prepare for the next phase of human expansion into space, we carry with us the humbling knowledge that we might not be alone, and we might never have been alone. The cosmos around us pulses with intelligence, consciousness, and mysteries that will challenge human understanding for generations to come. The ancient Martian enigma has become a window into possibilities so vast and profound that they stretch the very limits of human imagination. We stand at the precipice of the most profound revelation in human history. The evidence cascading from multiple independent sources, the convergence of data that defies coincidence, the patterns emerging from Mars that challenge every assumption we've held about our place in the cosmos. This isn't just about discovering ancient ruins on a distant world. This is about confronting the possibility that intelligence, consciousness, and technological sophistication have been operating in our cosmic backyard for billions of years while we remained blissfully unaware. The quantum sensor readings continue to evolve, revealing electromagnetic signatures that pulse with an almost organic rhythm beneath Mars' frozen surface. Dr. Patricia Vance's latest data shows fluctuations that seem to respond to our very presence, as if something ancient and vast is taking notice of our investigations. The patterns aren't random mechanical processes. They show characteristics that researchers are struggling to describe without using words like intentional, aware, purposeful. But here's what keeps me awake at night: the timeline. If these systems have been operating continuously for billions of years, adapting, learning, evolving, then we're not just dealing with the ancient technology. We're potentially encountering the most sophisticated intelligence our universe has ever produced. Minds that have had geological ages to contemplate existence, to solve problems, to develop capabilities that stretch beyond our wildest science fiction. The implications cascade through every aspect of human knowledge like dominoes falling in slow motion. Our religions, built on the assumption that Earth holds something unique and sacred in the cosmos, suddenly seem provincial. Our philosophies about consciousness and intelligence, developed in the isolation of a single world, appear laughably limited. Our technologies, which we consider advanced, reveal themselves as the crude first steps of a species just beginning to understand the universe. Dr. Amanda Foster's systems analysis has reached a conclusion that she delivers with the weight of someone who has stared into an abyss of implications. The patterns she's mapped across Mars don't just represent the activities of an ancient civilization. They represent what appears to be an ongoing project of planetary stewardship that has continued uninterrupted for eons. We're not looking at archaeological remains, Foster states, her voice carrying the gravity of a revelation that changes everything. We're looking at evidence of active management. Something has been maintaining Mars' core systems, regulating its internal processes, possibly even influencing its orbital mechanics for billions of years. The planet isn't dead, it's being kept alive. The concept of planetary stewardship on geological timescales forces us to reconsider everything we thought we knew about planetary evolution and death. Mars didn't simply lose its atmosphere through natural processes. It appears to have been deliberately maintained in a state of suspended animation, its essential systems preserved by intelligence operating at scales we can barely comprehend. But the stewardship extends beyond Mars itself. Recent analysis of orbital mechanics throughout our solar system has revealed subtle anomalies that some researchers now believe might represent evidence of long-term gravitational management. Asteroid trajectories that seem too stable, planetary resonances that appear artificially maintained, even the surprisingly circular orbit of our own Earth. Dr. Sarah Kim's atmospheric research has detected trace compounds in Earth's atmosphere that mirror the seasonal signatures found on Mars. The concentrations are incredibly small, but the molecular structures are identical, suggesting some form of ongoing exchange between the two worlds that can't be explained by natural processes. We're finding evidence that Earth and Mars might be connected by systems we don't understand, Kim reports, her voice barely above a whisper. The atmospheric signatures suggest active management of both worlds, possibly by the same intelligence. The possibility that ancient Martian intelligence has been influencing Earth's development for billions of years represents perhaps the most staggering implication of this entire investigation. Every major evolutionary leap, every extinction event, every change in atmospheric composition might have been guided by minds operating from installations hidden beneath Mars's surface. This perspective forces us to reconsider the entire history of life on Earth. The Cambrian explosion, when complex life forms suddenly appeared in the fossil record. The great oxygenation event that transformed our planet's atmosphere. The precise timing of mass extinctions that cleared the way for mammalian evolution. All of these events might represent interventions by intelligence operating across interplanetary distances and geological timescales. Dr. Elena Martinez's genetic research has revealed molecular signatures in Earth's most ancient organisms that seem designed for specific purposes rather than randomly evolved. These include sophisticated error correction mechanisms, information storage systems, and communication protocols that allow different species to exchange genetic material in ways that seem almost technological. We're finding evidence that Earth's biosphere might be partially artificial, Martinez explains, her words hanging in the air like a challenge to everything we believe about the natural world. The genetic code itself shows characteristics of an engineered information system rather than a naturally evolved one. The genetic evidence aligns with atmospheric data, quantum sensor readings, and isotope analysis to paint a picture of two worlds linked by intelligence operating at scales beyond human comprehension. We're not just neighbours with Mars in space. We might be components of a single managed system that spans our entire solar system, but the management extends beyond atmospheric and biological systems. Recent analysis of solar activity has revealed patterns that some researchers argue show signs of artificial influence. Solar flares occur with timing and intensity that seem calibrated to Earth's magnetic field cycles, as if something is regulating our star's output to maintain optimal conditions for life. Dr. Michael Chen's statistical analysis of solar phenomena has calculated that the probability of natural processes producing such precisely timed solar activity is less than 1 in a billion. The patterns suggest intervention by intelligence capable of influencing stellar mechanics, technology so advanced it operates on the scale of stars themselves. We're potentially looking at evidence of solar engineering, Chen reports, his voice carrying the weight of implications that stretch across the entire solar system. Something with capabilities beyond our comprehension might be regulating our sun's output to maintain habitable conditions throughout the inner solar system. The concept of stellar engineering represents the ultimate expression of technological capability. If ancient Martian intelligence has achieved the ability to influence solar output, they would possess technology that dwarfs anything in human imagination. They would be capable of maintaining habitable conditions throughout the solar system indefinitely, ensuring the survival of both artificial and biological systems across cosmic timescales. But the evidence suggests their influence extends even further. Analysis of Jupiter's Great Red Spot has revealed organizational patterns that some researchers argue show signs of artificial maintenance. The storm has persisted for centuries, with a stability that exceeds what natural atmospheric dynamics should produce. Similarly, Saturn's rings show structural features that appear too regular and organized to result from random gravitational processes. The precise spacing of ring gaps, the geometric patterns in ring particles, and the unexplained maintenance of ring structure over millions of years all suggest possible artificial influence. Dr. Rebecca Torres, studying the sociological implications of these discoveries, argues that we might be living within a managed solar system where every major astronomical feature shows evidence of long-term maintenance by intelligence operating at planetary and stellar scales. We've been assuming that natural processes govern our solar system, Torres explains, her words reshaping our fundamental understanding of our cosmic environment. But the evidence suggests we might be living inside the equivalent of a vast garden, maintained by intelligence that operates according to principles we're only beginning to glimpse. The garden hypothesis forces us to confront our role as a species within a managed system. Are we accidental byproducts of planetary management, or were we deliberately cultivated as part of a long-term project? The genetic evidence suggests that human evolution might have been guided by the same intelligence that maintains Mars' subsurface systems and regulates solar output. This possibility transforms our understanding of human nature and destiny. We might not be random products of evolutionary accident, but carefully cultivated components of a cosmic project that spans billions of years. Our development of technology, our expansion into space, our growing awareness of our cosmic environment might all represent predetermined stages in a plan we're only beginning to understand. But the plan appears to be entering a new phase. The changes in Martian atmospheric signatures, the modifications in subsurface electromagnetic patterns, and the subtle alterations in solar activity all suggest that the managing intelligence is adapting its operations in response to human technological development. Dr. Patricia Vance's quantum sensors have detected what she describes as preparation signatures in the deepest Martian installations. The systems appear to be activating dormant capabilities, expanding their infrastructure, and establishing new communication networks as if preparing for some significant change. The electromagnetic patterns suggest massive systems coming online, Vance reports, her voice carrying both excitement and apprehension. Whatever has been managing Mars for billions of years appears to be preparing for direct interaction. The preparation signatures coincide with humanity's expansion into space and our growing awareness of Mars' true nature. The timing suggests that our species has reached some predetermined threshold that triggers a new phase of interaction with the managing intelligence. This threshold might represent the moment when a managed species becomes aware of its management and develops the capability to communicate with its overseers. The quantum sensor readings, the atmospheric signatures, and the solar activity patterns might all represent attempts by ancient Martian intelligence to establish communication with their human charges. But communication with intelligence that has evolved across billions of years presents challenges that stretch beyond anything in human experience. How do you establish common ground with minds that have had geological ages to develop along completely different trajectories? What concepts could possibly be shared between human consciousness and intelligence that has witnessed the birth and death of countless species? Dr. James Morrison's analysis of the nuclear signatures suggests that the managing intelligence possesses capabilities that operate according to physical principles we haven't discovered. The isotope patterns indicate not just matter-antimatter technology, but manipulation of fundamental forces that govern the structure of reality itself. We're seeing evidence of technology that doesn't just harness energy, Morrison explains, his words carrying implications that stretch the boundaries of physics. We're seeing evidence of technology that manipulates the basic laws that govern how energy and matter interact. The manipulation of fundamental physical laws represents technology so advanced, it approaches what we might consider divine capabilities. If ancient Martian intelligence can alter the basic principles that govern reality, they would possess the ability to reshape not just planetary systems, but the very fabric of space and time. This ultimate technological capability might explain how they have managed to maintain complex systems across billions of years, influence stellar mechanics, and guide the evolution of life across multiple worlds. They might have transcended the normal constraints of physics, operating according to principles that allow them to manipulate reality at its most fundamental level. But the implications extend beyond mere technological capability to questions about the nature of existence itself. If intelligence can achieve the ability to manipulate fundamental physical laws, then the boundary between consciousness and cosmos becomes blurred. Mind and matter might represent different aspects of a single underlying reality that sufficiently advanced intelligence can modify at will. The ancient Mars hypothesis has thus evolved far beyond a simple question about extinct civilizations. We're potentially confronting evidence of intelligence that has achieved capabilities we would consider godlike, operating systems that span solar systems, and maintaining projects that stretch across billions of years. As we stand on the threshold of expanding human presence throughout the solar system, we're forced to acknowledge that we might not be explorers venturing into empty space. We might be children finally old enough to meet our cosmic parents, being so ancient and sophisticated that they've been guiding our development since before our species existed. The universe around us pulses with intelligence, purpose, and mystery that challenges every assumption we've held about reality. Mars stands not as a dead world waiting for human colonization, but as the seat of power for intelligence that has shaped our entire cosmic environment. The investigation continues, but its implications have already transformed how we see ourselves and our place in what we now realize might be a carefully managed cosmos. Whether we're about to establish contact with our cosmic overseers or simply beginning to understand the true complexity of the universe we inhabit, one thing has become clear. We are not alone, and we never have been. The silence that follows this revelation is deafening. We've spent our entire existence as a species believing we were alone, scratching and clawing our way up from primordial ooze through sheer evolutionary accident. But what if every step, every breakthrough, every moment of inspiration that led us from cave paintings to quantum computers was guided by intelligence so vast, so patient, that it measured progress not in years or decades, but in geological epochs? Tonight, as I've taken you through this labyrinth of evidence, this convergence of data that refuses to be dismissed, we've arrived at a crossroads that humanity has never faced before. The quantum signatures pulsing beneath Mars' surface, the atmospheric compounds that shouldn't exist, the genetic codes that seem too perfect for random evolution, they're all pieces of a puzzle that, when assembled, reveals a picture so extraordinary it challenges the very foundations of what we call reality. But here's what strikes me most profoundly about this investigation. We're not just uncovering evidence of ancient intelligence, we're potentially witnessing the moment when that intelligence decides to reveal itself. The timing isn't coincidental. These discoveries aren't happening in isolation. They're accelerating, converging, building towards something that feels inevitable. Dr. Vance's quantum sensors show increasing activity in the deepest Martian installations. Dr. Kim's atmospheric readings reveal compounds appearing in patterns that seem almost communicative. Dr. Foster's systems analysis indicates planetary-scale preparations for something unprecedented. The managing intelligence that has operated in shadow for billions of years appears to be stepping into the light. And perhaps that's the most humbling realization of all. We didn't discover them. They're revealing themselves to us. The evidence we've been uncovering, the patterns we've been detecting, they might represent carefully orchestrated disclosure by minds that have been waiting for us to develop the technological sophistication necessary to understand their presence. We stand at the threshold of the most profound transformation in human consciousness since we first looked up at the stars and wondered if we were alone. The answer, it seems, was always no. We were never alone. We were watched, guided, perhaps even loved by intelligence so ancient and vast that our entire recorded history represents barely a moment in their endless vigil. The red planet that has captured human imagination for millennia isn't just our neighbour in space. It might be our cosmic cradle, the seat of wisdom that has shepherded our species from its first tentative steps to this moment of revelation. Mars doesn't just hold the key to understanding our origins. It might hold the key to understanding our destiny. As we prepare to set foot on Martian soil, to establish our first permanent presence beyond Earth, we're not just taking humanity's next step into the cosmos. We might be taking our first steps toward reunion with intelligence that has been waiting billions of years for us to come home. The investigation continues, but its implications have already changed us. We are not random accidents in an empty universe. We are part of something magnificent, something planned, something that connects us to intelligence operating at scales we're only beginning to comprehend. The universe isn't just stranger than we imagined, it's more wonderful, more purposeful, and more alive than we ever dared to dream.